All right, as we begin today, I want you to have out your homework, and we're going to start with the second part of the homework, those two equations that you were supposed to analyze. The first equation being a y squared is equal to x plus 4. And as we analyze the equation, the first thing we want to analyze is intercepts. We want to determine what's the x-intercept, what's the y-intercept. Again, the key to intercepts, class? Plug in 0. So for the x-intercept, we plug a 0 in for the y. And when I do, I get -4 for my x-intercept. For the y-intercept, plug in 0 for the x. And when I do, I get y is equal to positive negative 2. So we've got 3 intercepts to go off of here. Now, frankly, this might be enough to get a decent graph. If you remember that if 1 is squared and 1 isn't, we're going to have a parabola. But let's assume maybe we didn't remember all of that. We want to continue our analysis, or at least see if this is backed up. The next thing we check for is symmetry. And we check for symmetry to 3 things. First the, then the, and then finally the origin. All right, to determine whether or not we have symmetry, we don't plug in zeros, class, we plug in negatives. And for x-axis symmetry, we plug a negative in for the y. Can you put a negative right here for the y? Yes. Yes, because the square is going to change it right back again. There's no problem putting a negative there. It doesn't mess anything up. So the verdict on x-axis symmetry? Yes. It is symmetric to the x-axis, meaning what you see above the x-axis, what you see below the x-axis should match. Y-axis symmetry, what do we do? Put a negative where the x is. But if you put a negative x in for that x, that's going to change things, isn't it? So is it symmetric? No. All right, and then origin symmetry, I don't even have to check. If I get yes, no, I already know my answer is going to be no. You can have no, no, and then yes. You don't have to, but you could. If you have yes, yes, you're guaranteed to have a yes. But if they're conflicting, you're always going to get a no. Again, technically, you plug a negative in for the x and the y, but it's not all going to bounce right back. So there's our symmetry test. The last thing we're going to check, domain and range. And for the domain, that refers to all possible. But in order to see your possible x values, we want to set the equation equal to y. So if we set this equal to y, it's really close. All we have to do is, so we'd say that y equals the square root of x plus 4. And then we look at this and say, what can I plug in for x?
Anything bigger than -4?
-4 is kind of that critical value that would give you the 0. That puts you right on the edge. Anything bigger like -3, -2, -1, 0, 1, 2, 3, 4, 5, all the way to infinity is good. Anything below that, -5 on down, no good. So we'd say the domain is. All right, then the range. Range refers to all possible y values. So to see what possibilities exist for y values, the best way to do that is set the equation. And there for that, I'm just going to ditch the 4 and say y squared minus 4 is equal to the x. Thoughts on what I can plug in for the y? Anything. There's no limiting factors here, no limiting traits. So we just say all real numbers. For the graph, should have put an x-intercept at -4, y-intercepts at +2 and -2. We realize that we're going to see symmetry above and below, nowhere else. Domain is going to go from here all the way that way. Range is going to just continue to expand vertically in both directions. And so we do get this parabola formed there, and this is what our sketch should have looked like. How did we do on that? All right, questions? All right, let's take a look at the next equation then that you had to analyze for homework. Salvage that, be lazy. 2x squared plus y squared equals 8. All right, x-intercept, plug in. And when we do, we get positive -2. Divide the 2 to get 4, take the square root, we get positive -2 for the x-intercept. Y-intercept, plug in 0 for x. And when we do, positive negative square root of 8, or the best way to say that would be positive -2 square root of 2. Now, practically speaking, that's approximately what value? Calculate.
2.1. 2.82.
About 2.8. You know the square root of 9 is going to be a 3. This is the square root of 8, so it's just a little smaller than 3, about 2.8. So if you were plotting your intercepts, obviously 2 and negative 2 on the x is really straightforward. On the y, going to be like 2.8, negative 2.8. All right? Symmetry to the x-axis. Plug in. Negative for the y. Does it work?
Yes.
Yeah. For the y-axis?
Yes.
Plug in negative for the x, and yes, and if we get yes, yes,
Yeah.
of course it's going to be yes. Negatives for both, they're both going to change because they already did once before. So we're symmetric to everything. By the way, what shape am I thinking then?
Ellipse.
I'm thinking ellipse, though hyperbola is symmetric to everything, but the hyperbola usually will have no real intercepts for one of these. So I'm thinking ellipse. Let's check the domain. Domain refers to all the x values, so we're going to set the equation. So we're going to move the negative, the 2x squared over as a negative, take the square root, and there's our y. What can I plug in for the x?
Anything less than negative 2? No.
No, because if I plug in a negative 3, you square that, it's a 9 times 2 is 18. 8 minus 18 puts us into the negatives.
Negative 2 to 2.
Anything in between negative 2 and 2, right? You can't go bigger than 2. You can't go smaller than negative 2, but 2 and negative 2 both work. 1 and negative 1 will both work. 0 certainly works, right? So anything between negative 2 and 2. And again, if we were thinking of the ellipse, just stuff inside these two intercepts makes sense. All right, for the range. All possible? Set it equal to x. So we're going to ditch the y squared over as a negative, divide by 2, take the square root. What can I plug in here for the y?
Nothing bigger than a 4.
Well, a 4 squared would be a 16. 8 minus 16, ooh.
Nothing more than a 2.
Well, I mean, 2 squared is 4. 8 minus 4, that's still positive. That doesn't put me on the edge yet. A 3 just puts me over the edge, doesn't it? So it's actually a little bit smaller than that. What would I have to square to put me on the edge? If this value equaled an 8. So what would have to be squared? The square root of 8, right? Or the 2 squared of 2. So kind of the same thing. Anything in between negative 2 squared of 2 and positive 2 squared of 2. Again, anything between the intercepts. So in that case, that clinches it. We're definitely looking at a figure that hopefully doesn't look quite that bad. It's not supposed to look quite as much like an egg. It's supposed to be more like an oval than an egg. But anyway, you get the idea. Questions on this? Questions on this? Again, a little harder because it was an irrational value, not an integer value, right? But do we see the same thought process? This, again, if you want to think the mathy way, this has got to be greater than or equal to 0. Which means 8 has to be greater than or equal to y squared, which means y has to be less than or equal to positive negative square root of 8. Those are the separator points. Positive negative square root of 8. Try to go outside, plug in 3 and negative 3, you're in trouble. Go inside, try like a 2 or negative 2, 0, 1, whatever. That falls inside. That's the other way you could check that. Questions on this? All right, clear desk, except for a clean sheet of paper, pencil, and a calculator. Clean sheet of paper, pencil, calculator. And before we finish looking at the homework, let's take a quiz over those 3 analytic tools. You do not need to write anything on your paper. You're going to use your paper as a cover sheet. So just have blank paper, and you use it for a cover sheet. You'll take quiz 30 directly on my quiz copy. Take quiz 30 directly on my quiz copy. If you would, put your first and last name at the top of the paper. There's not necessarily a blank that says name. Just put your name up there in the space at the top. Also today's date, which is 2/9/22. 2/9/22, today's date. Fairly straightforward. I've given you one equation. I want you to fully analyze it. And then at the bottom of the graph, at the bottom of the page, graph it on that graph grid. Remember, this is a graded graph. So make sure you set up the graph grid correctly, shall we say. All right, you may begin.